Hello, everyone. I'm Quentin de Hulst. I'm Director Green Field Building at the European Copper Institute. It's the third webinar of the Zero Emission Buildings Academy that is a partnership between the European Copper Institute, the European Construction Technology Platform, and the Building Performance Institute Europe. Today, we will discuss about energy performance contracting and how to unlock the energy efficiency potential of this tool. So how can we just pay as we save? That's maybe an easier word for the concept of energy performance contracting. And for this, I'm pleased to welcome two speakers today, Anthony and Romain. They are both engineers. Anthony is group pre-sales for the smart building projects at Elexia since 2 years. He worked for major industrial leaders and software scale-up in France, Belgium, and Spain before that, and he's engineer in energy and operational efficiency. Then we will also have Romain, who is working as product manager and product expert at EnergyRisk since 2016, where they developed Energy's Cloud, an energy management system. And he's civil engineer, but also he has a PhD in applied mathematics. The link between both of them is that they are co-supervisor of a work package of the BIGG project, and they will explain what it is, but it aims to build an artificial intelligence toolbox designed to solve building-related problems, among which energy performance contracting management stands. So there is a lot of potential to improve energy efficiency by better management, better investment in the buildings, but there are several barriers, usually with the investment for it. And I think energy performance contracting is a very interesting solution for this. So now I'm pleased to give the floor to Anthony, who will start with a presentation of the project and what they achieved. And then we will have a demonstration of the tool by Romain. So I remind everyone, please put your questions into the Q&A menu, and we will take these questions after the presentation. So Anthony, the floor is yours. Thank you.
Thank you, Quentin. All right. Good afternoon, everyone. So as I said, today we are going to go through the energy performance contracting management toolkit that the BIGG project is involved into. So let me first introduce a little bit the contents we are going to go through today. First of all, a simple explanation of the BIGG project, which is part of the H21 2020 European project. We are going through an explanation of the energy performance contract and how does the artificial intelligence aims to optimize the energy performance contract management and monitoring itself. And then we are going through the demonstration itself, which Romain is going to handle later on this presentation. So, as I said, the BIGG project is part of the H2020 program. The goal of this project, composed of an ecosystem of partners and several companies and universities in Europe, is to demonstrate the application of big data in analytics regarding the energy efficiency optimization. We have developed a harmonizer layer. We have developed an artificial intelligence toolbox, and also we developed use cases where we can apply the techniques we developed within the BIGG projects. One of these business case is the energy performance contract management optimization, in which Elexia and EnergyRisk are working on since 2020 now. So let's dive into the energy performance contract management itself. Let's take a scenario where we have an industrial company named AZ Limited, which has an outdated production facility which needs to invest into energy efficiency for operating cost reduction, but also to comply with some regulations which are European or linked to the country. So basically, the company lacks the funds and technical expertise but also the management team is unsure about what techniques and upgrade should fit the industrial facility. In that case, AZ Limited should, for example, try to engage discussions with an ESCO company. An ESCO is the energy service company, which company can offer turnkey solutions like the energy performance contract package, which helps any industrial, any tertiary facility to finance and promote energy efficiency actions with guarantees. Above all, the artificial intelligence tool that we developed helps optimize the monitoring of the equipment performance and maximize the energy efficiency gains. So in the end, there is a partnerships that is constructed between the company itself, so the customer, and the energy service company, in order to make a win-win in energy efficiency and financing these actions. Basically, the energy performance contract, as I said, is a contract between a project owner and an operator specialized in energy service, such as Alexa, for example. Basically, it contractually guarantees a reduction in the energy efficiency consumption, and there is a financing plan which is being made during all the contracts. There are two kinds of energy performance contracts. The service, which involves, for example, the maintenance of the equipment system, installation of an energy management system, or more technical contents like the building management systems, which helps gains between 10 and 20% savings per year, but also the works and service EnPC, which now involves more investment and actually helps change the way the buildings is consuming energy through different actions, which are heating, cooling, ventilation, lighting, etc. So basically, an energy performance contract is a transfer of risk from the ESCO company and the clients. Transfer risk, speaking about financial and technical risk. How is it financed? Basically, we have the AZ Limited company consumption before any actions into the building. So the ESCO, in that case, in the case where the client wants to work with the ESCO itself finance every actions that should help the company reduce the consumption. So let's say we have energy efficiency actions now. We do have savings regarding the energy consumptions afterwards. The energy efficiency actions are being made during all the contracts, which can be between 4 and 15, 20, 12 years, it depends. The investment being made by the ESCO company is being financed during the whole duration of the contract, but there is a energy savings guarantee, which guarantee the clients that all the actions are going to be rentable and fundable at the end. Above all, the clients can also take into account that they can, in some cases, receive some green certificates or subsidies from the country or from the European Union, for example. After the termination of the contracts, the client is going to receive all the benefits from the actions. Like, for example, if we install a new lighting system, the lighting system is going to remain into the client's site. And after the duration of the contract, they will receive, of course, all the savings from these actions and have all the benefits of it. There are 4 steps to construct and design the energy performance contracts. Basically, the first step is to identify the energy efficiency actions that we can engage into a building. So basically, it's by performing an energy audit. We can identify a list of actions, which actions can be, let's say, designed to see if it can help the client reduce its energy consumptions at a good price. After that, we do the feasibility study, which is technical and financial feasibility study, which then goes to a financial plan that has to be approved both by the ESCO company and the clients. Then there is the contractualization phase, where when the ESCO company and the clients agrees in the terms of the contract, they are going to work on creation of a baseline consumption, which helps to guarantee the performance, the energy performance, and to follow up the efficiency of the actions during all the duration of the contracts. They sign the energy performance contract, and after the signature of the contract, they go through the implementation of the energy efficiency actions into the buildings, and of course, the performance monitoring of the contract itself. At the end of the contract, the ownership of the assets being installed and implemented into the buildings are the ownership of the clients. And where does the big project helps all of this? Basically is within the two last phases, where the big projects and the big data model and AI toolbox that we designed help us, both ESCO and clients, to have a more powerful, let's say, energy baseline conception, to have a more powerful operation and performance monitoring. So basically, how does the big project help us create a powerful baseline? Let's first go deep into what exactly is the baseline and see a little bit how it's been constructed into this kind of energy performance contracts. So before any actions, we see the historical consumption of the buildings, which are measured. So this is historical consumption, the blue line. We do the energy efficiency actions. Before any actions, we use this baseline to imagine what would be the consumption if we wouldn't have any actions into the buildings. So without any actions, the blue line would be following the red line, basically. So this is the adjusted reference consumption. But in the end, we did actions into this building, which is the orange dots. The actual consumption measured after the implementation of the actions is the blue line, which is now less than the red line, because we assume that we were able to save, for example, 15 or 20% of the estimated consumption, which in the end generates savings, which are the green area. This is how the energy performance contract is based. Of course, you can clearly see that it's based on the EPM-VP protocols. That's why the big project helps us generate a powerful baseline consumption. Roma is going to go really deep into this baseline consumption to explain how powerful is it. Then collection and standardization, and of course, harmonization of client data, which means energy data, which means building data, portfolio data, etc. This is really something essential, and the big project involves harmonization layer, which helps us to standardize all this data into simple data sets that is which aims to be open and the more flexible as possible. And then in the end, the big project and big data model helps us make a good monitoring of the energy performance contract itself. So this is the step where the actual consumption within all the duration of the contract are being followed up, and we just simply see if the actual performance of the actions are in track or not in track. And this kind of powerful baseline consumption and energy monitoring system can help us detect any drift, detect any non-efficient actions, etc. So this is really something that helps both the clients have the energy efficiency actions in the end, and the ESCO company to be compliant with its commitments into the energy performance contracts. And all of this is managed and designed within the framework of the EPMVP protocol. That's why the ESCO company should be a CMVP, so Certified Measurement and Verification company. I think to understand a little bit more about the contents we shared, the best way to do so is by showing the actual system that Roma is going to show us.
Thank
I
you,
give you
Anthony.
the hand.
I will take over the screen. All right. Let me know if it's okay on your side.
Perfect.
Okay, perfect. Okay, I will illustrate what Anthony just said with two pilot sites that we followed during the big project. Like Anthony said, it's a European project with a European consortium. And we have worked in particular with multiple ESCO companies, in particular two ESCOs, Cordia and Elexia. Cordia is based in Greece, and Elexia has already been presented by Anthony. And so the tools that I'm going to present now, I'm going to illustrate them on two different projects managed by two different ESCOs. So really the goal of that we tried to achieve was to come with a solution that is flexible enough, generic enough, so that it can adapt to multiple cases. So like Anthony said, the first place where the first contribution of the solution that we designed will be with the contractualization phase. And I want to show you a few things. What I will show you now is what is a solution that has been built with the Energies Cloud platform that is developed at Energies. However, the tools that we designed, the principles of generalization of energy performance contract, is something that goes beyond the. But what you will see now, all the screens have been created with the Energies Cloud platform. So the first thing, like I said, was the contractualization phase. So the first thing first, we have created all the assets of the contracts within the platform. So collecting all the data, both the address and all this type of data, but also collecting all the consumption data. This is typically the role of an energy management system like Energies Cloud, right? So it's collecting all of this data. And then for the contractualization phase, where the platform and the tools that have been developed in the big project help really much, is to identify a baseline model of the consumption. So this figure here is a bit the equivalent as what Anthony showed you before. Right, you see, before any work is happening here, this is the historical data period. Then we have some renovation works that lasted for a few months. And after that, after this renovation, we start to measure some savings. Okay, so before the works, we have the actual consumption, and using this consumption, using the weather conditions, the occupation conditions of the site and so on, and the artificial intelligence toolbox that has been developed in the big project, we come up with a good baseline model. Actually, the two lines of the model and the actual curve, you cannot really distinguish them because they're really, really close to each other, because the model is actually quite accurate. And then we basically project what the building would have consumed if no renovation had happened. This is the dark green line, right? And the actual is the light green line. And the difference between the two, the dark green area, is the savings that you generate. The model, the better the estimate of the savings. So the more reliable these savings are, and the more cost you get from the customer, right? You can also here see a view of the cumulated savings and stuff like that. Now, just to one of the important components with the big project was that you have basically you need to cope with two different situations when coming with energy performance contracts. Maybe you are an ESCO with you want to enter the market of energy performance contracts, and you want to launch new contracts. In that case, you are looking for a way to find accurate baseline models. And that is one of the components that the big project allows to do. So we have this AI toolbox that allows you to find very good models like the one you see here. But you might also be an existing ESCO with already a lot of existing contracts. And if these contracts have already started, then you have already a baseline model that has been contractualized and that we want to use also. This is also something that you need to be able to do. And collecting in both cases need to be feasible, and the big architecture that has been created allows for that. Just to show you, we have exactly this case here with, so this is the reference period that you saw before, and we are comparing the model created with the AI toolbox with the one that was created using standard linear regressions with Excel, right? So you see that it's decently accurate, but you get a much higher degree of accuracy when you're using like regression models a bit more powerful. So well, that's really the first contribution, is to integrate all the data, create these baseline models, or integrate existing baseline models in order to get to start measuring the savings. Then the works actually happen, and you want to operate the savings, to follow the savings up. All right, so for that I will try to my next tab is not available. Earlier it was working, so how can I get rid of this? So this is not sure. Maybe if I do this. No, that's not it. Maybe if I do this. Okay, better like that. Sorry about that technical problem with the Zoom tools that are in front of my tabs. But here it is. Okay, so now I'm going to show you the savings follow-up that we can achieve with after we have integrated all this data. I will start by illustrating that with this industrial site. So we have one site which is an office building managed by Cordia, and another one which is an industrial site managed by Electia. So we see there's a wide variety of buildings managed by different ESCOs. So it's really to illustrate what standardization can provide as an output. So in this screen, what you can see first is so now we are after the project started, right? So the project was implemented in 2018, and after that we started to measure the savings. And what you see here is the baseline model. So it was the before work situation. And from an analysis made during the feasibility study, a savings percentage target is identified, right? And this is also visible on the chart, okay? Then you want to follow how close to this target you are. And there's also this idea that if you perform even better than the target, then you should be rewarded for that. So there's also this component that can also be taken into account. So here we have a bonus and malus area, let's say. So if you're within the dark yellow area, you're in basically in the expected range, like performing as expected. And you can follow up with this type of chart. You can follow up if you are whenever you are within the expected range of consumption, or lower. In this case, there's a lot of lower consumption appearing here, and also when you're above, you would have some malus. Okay, so you see here that in this case, in a lot of a big fraction of the time is spent in a bonus area, meaning that the ESCO company is expected, and that's contractual elements that need to be agreed in advance. And the ESCO will expect to receive a bonus because they do even better than expected, right? So they were expecting a certain 52% of savings and actually reached more than that. Yeah. And you can also follow up savings in time, also in accumulated way and so on. Right? So you have a global view on your savings. One slightly technical element, but it's important, is that these savings, they are on different, they are made on different scopes. So in this case, for instance, there are some savings expected on electricity and other savings on gas. So we can, for instance, zoom on the electricity, and you can see here that in this case, this particular project is mainly about gas consumption. Electricity plays a little part of it. The numbers are quite low in the expected savings, and the percentage, the target percentage is also quite low, but the weight overall on the total is quite low as well. Then you also have the gas part, and here the target is much higher, and the system will automatically combine all these scopes to have a global overview, which stands for both the electricity and the gas. But it's important here that any project will be different. For instance, here in the Cordia case, the office building, we are talking about electricity and oil and not gas. But in other cases, you might encounter very specific scopes, like one scope about lighting, or one, it can be quite different depending on the cases. So this is the first part of the analysis, the follow-up of the savings. Now the next step is to follow up the contractual elements. You know that how will the ESCO be paid, as Anthony mentioned before? Well, the customer will pay for a certain fee every month. They will pay a recurring fee, right? And in this case, in the case of this contract with Electia, at the end of the year, we need to evaluate if the savings over this past 12 months have been better or worse than expected. So if there is a bonus or malus owed at the end of the day, right? And this is the case, right? Remember that in this case, there is a bonus, which you see here. So at the end of the year, the customer should majorate, in this case, the fee to account for this bonus. So in the end, you have the if everything happens normally, fee adjustment, an adjustment factor, and in the end, what the ESCO earns from this project. Then you also have the customer side, right? So the customer on his side is paying the fee every month, right? You see the blue part again, plus the bonus owed to the ESCO, but it can be frustrating to pay a bonus. But on the other hand, obviously, if they pay the bonus, it's because they made a lot of savings. So the green part is the savings made by the customer, and you can compare what they pay to the ESCO versus the savings made and the balance, which is clearly always guaranteed to be in their favor. Voilà. So that's a bit how it goes with the tools that have been developed, and that was the case of this industrial site managed by Electia. Now, just to illustrate how it changes when you go to for instance, to how Cordia is dealing with energy performance contracts. It's excuse me. The same logic applies, but with a few differences in the way the contract is built. So here you again see the same type of graphic where you have the baseline consumption in green, the targets here in red, the 12% target, In the case of Cordia, the logic is more that you make a guaranteed savings target. So the ESCO here will guarantee the savings. If the savings are lower than this 12%, they will compensate to guarantee the savings. Then any savings that is beyond this target will be split with a certain share to be determined in the contract. Yeah, so here clearly the expected case is that we will always be lower than the target, otherwise there's something really wrong, and the bonus, the extra will be shared among all the stakeholders. So it's in this case quite expected to do better than the target because it's quite conservative. So it's a different logic, and it also works with the standardization process that has been put in place with the project. Now, when it comes to the financial aspects, same logic, but here, since there is never malus to be paid, the bonus is paid every month instead of at the end of the year. So it's a little bit different, but at the end of the day, it's the same principle. So the customer in total over the year has owes the ESCO a certain amount, which accounts for this bonus. In this case, the bonus is digressive over time. So the more you reach the end of the contract, the less the less percentage should be shared by the end customer. This is different from contract to contract. And again, the balance for the customer, where you see he can compare what he pays to the ESCO versus the savings made and the overall gain with this project. And with this, I would like to finish with this screen. Maybe I will give the floor back to either Quentin or Anthony for the conclusion.
Thank you, Romain, and thank you, Anthony, for this very good and clear presentation.